Hey everyone, and welcome back to Gaffy's Grinds. In this video, we're going to do the 2016 question, question 6, part C. So it's the calculations on heats of reaction question. So we have been doing a few of these in this playlist, and I suggest that this shouldn't be the first one you should watch because we're now getting to the stage where we've sped it up. I'm not going to be giving you as much help. So I suggest you go back and watch the 2020, 2019 videos first, and then come back to this one. All right, so what I'm going to do is I'm going to ask you to pause the video and I'm going to ask you to read from here to here. Do that now, please. All right, so you'll be noticing that this is seems to be given a little bit less information than normal. There's only two heats of formation given, and that's because yes, it is an easier question. This was pretty straightforward, pretty easy. Okay, well, as you can see, it's interspersed with other little questions. So, name the oil refining process that converts this. Explain why this conversions are desirable. So these were parts of the question that you could easily miss that they were there. You had to give answers for them. So there's 1, 2, but then this here is where the calculation begins. So this is where we're going to focus on this third bullet point. Calculate the heat of reaction for the conversion of octane to ethyl benzene, given that the heats of formation of octane and ethyl benzene are these respectively. Okay. So first of all, I see that there's a typo there. This was the original one. So there should be an arrow here like this. Okay. So maybe we'll just work from up here because that's not great. So here you can see that this is octane going to ethyl benzene plus hydrogen. Okay. So what we got to do is derive there's two equations to derive from this information given up here. So pause the video and do that now, please. Okay, so what are we doing? We are given, in a purple highlighter, we've got given that the heats of reaction for the formation of octane is the first name, octane, and that is this number here, this formula here, CH18 is octane, and that's this number. And then the second chemical that we're told about is ethyl benzene, which is this chemical here. Of course, we're not interested in the other one. We won't have any heat of formation for that because H2 is an element. So this is minus 12.5. Okay, so derive the two equations. So basically, you're doing a heat of formation of octane first. So let's form octane, C8H18. Okay, and that forms, of course, from carbon plus H2. Balancing them out, you've got 8 Cs plus 9 H2s. And that has a delta H value equal to minus 250.1. All right. If you weren't able to do that one, I'm going to ask you now to pause the video and do the second one. Do this one right here, the heat of formation of this. Okay, so we're obviously forming C8H10 this time. Okay, and we're forming that from carbon plus hydrogen again. Okay, but this time it is, how many carbons? We've got 8 carbons this time, but only 5 hydrogens, 5 H2s. Okay, and that gives me a delta H equals to minus 12.5. Okay, right. The next thing then is where it says, as you see, it says, what are we looking for? What are we looking for? Well, if we go back up here and read, it says, calculate the heat of reaction for the above conversion. Okay, so it's given us the reaction. Is this one up here, or more specifically, this is probably better here. So what I'm going to do is ask you to pause the video, write this down underneath where you've derived your two equations, put a box around it. Do that now, please. All right, so that's obviously, we've got C8H18, and it's splitting into C8H10 plus 4 H2s, is it? Yeah, 4 H2s. Okay, and the delta H for this is, that's our question mark. So putting a box around that, that's the big important information. We've got two smaller steps or two smaller equations that we can consider and get information from. And what we want to do is manipulate them to get them to add up to the big equation here. All right, so you've seen how we did this in the other videos. What I'd like you to do now is pause the video and beside these two here, write down what manipulations are we going to do to equation 1 and equation number 2 to basically turn them into the main equation. Okay, pause the video and do that now. Okay, so the first thing I'm noticing is that the compound here, this C8H18 that's been formed, is in the products here. So this here is the products because on the right-hand side of the arrow, whereas down here, it's a reactant. So when we have this and we want to take it and put it into the reactants, what we need to do is reverse this whole equation. And when we do that, we reverse the equation, that also gives us the opposite sign. Okay, because changes sign. And the reason why it changes sign is because this is an exothermic reaction when we form C8H18. If we were to then take that same substance and break it down and give back the elements, that would be an endothermic process. That would take in energy to do that. Okay, what about the second equation? What would we do to it? Okay, so hopefully what we said here is we just leave it, because here we've got C8H10 in our products. So this is a prod, it's on the right, and it's in the products here as well, it's on the right. Now you might be thinking, what about the H2? Why didn't I do anything with that? Well, this is an element, so it doesn't have a heat of formation, so it doesn't have a number associated with it. So I know you're probably seeing the H2s here and thinking, why am I moving that? Well, you're not moving that because it's an element. I'm only interested in compounds. Okay. All right, so we're going to leave this one. We're going to leave it. Just rewrite it the way it is. So pause the video now, and in the space below the box here, so this space down here, what you're going in the space below this boxed equation, so anywhere underneath that where you've written it on your page, you're now going to rewrite out these equations with the manipulations done. So if you said reverse, you're going to reverse. If you said multiply it by something, you're going to multiply it by something. Pause the video and rewrite them out now. Right, so we said up here for equation 1, we needed to reverse the whole equation, which means that we need to start like this. C8H18 is in the reactants now, and without it's breaking apart to give us 8 C's plus 9 H2s, like that. Okay, and that has a delta H equals, and it takes that number and changes the sign. It's my plus 250.1. Okay. All right, and then the other one we said we were just going to leave it. So that was 8 C's plus 5 H2s react to make C8H10. And that is giving me a delta H of minus 215. No, not minus 215, minus 12.5, sorry, 12.5. All right, so I'm finished with the above. I'm just going to scroll down, make more space. What I want to do now is add up the equations, cancel out anything that appears on both sides and see what's left. Okay, so see 8 C's cancels with those 8 C's, because I've got 8 C's in the products here and 8 C's in the products on the top, 8 C's in the reactants in the second reaction, so they kind of cancel out. All right, what else do I see? I'm seeing a 5H2 here. Okay, so I'm seeing a 5H2 reacting or canceling out 5 of these H2s, and that leaves behind a 4. Okay, so hopefully you can see what I've done here. 5 H2s cancel out 5 of these H2s, and that leaves behind 4 H2s. So that's it then. Okay, so I'm going to rewrite what I've got left. C8H18, that's the only reactant I've got left. Arrow makes C8H10. And now this is 4H2, so plus 4H2s. Okay, so does that match up my main equation? Yes, it does. Is exactly the same as this here, which is what I wanted to try and do. Okay, so now what I'm going to do is also sum up or add up these numbers here, and that will give me my final answer. So pausing the video, I'm doing that now. Okay, so when you do this, you should get delta H equals to 237.6 kilojoules. Okay, and that is the energy change, and of course this is now positive, so this is an endothermic process. Okay, so this reaction up here, this main reaction, or this one, is an endothermic process. Right, guys, so it was slightly a bit different. It was quite an easy one, I think. Again, you just have to deal with what they give you. Okay, so you can't be trying to learn off an exact method. Oh, there's going to be 4 equations I need to do, or there's going to be 3 equations and one of them needs to be reversed. No, it's not like that. You just have to deal with what they give you and interpret and apply what you've done before to the problem they give you. All right, guys, that's it. I hope you found this useful. If you find that difficult or you have any questions, if you ask them in the comments below, then I can deal with them. I can make a video for you and answer them. Also, if you can, if you want to, if you found this useful, if you like or subscribe to the video, that sometimes helps other students who might be looking for the same thing to find it. Okay. All right, guys, I'll see you in the next video. Thank you.